Hello friends, welcome back. Let's look at some examples where x is not tending towards 0 but tending towards a non-zero value like either pi by 2 or a, something like that. So what is the approach we have to follow to solve these problems? So what I will try to understand now is that we have the problem cos of x divided by x minus pi by 2 as x tends to pi by 2. If you remember all our formulas, whatever we have, sin of x by x, if I say limit of that as x tends to 0 equal to 1. So obviously I have to convert this into another variable, and that variable should tend to 0, then this will be okay. So for that what I will do, now if you see here x tends to pi by 2, what is the meaning of that? Can I say x minus pi by 2 tends to 0? Now there you have your answer. That means we have to take a variable y such that y equal to x minus pi by 2. Then what happens? Then this limit will become limit of y tends to 0, because as x tends to pi by 2, x minus pi by 2 tends to 0, but x minus pi by 2 is nothing but equal to y. Limit y tends to 0, I will have cos of x is nothing but y plus pi by 2 or pi by 2 plus y divided by x minus pi by 2, that is nothing but equal to y. Now what will be the next step for this? The next step will be, as y tends to 0, what is cos pi by 2 plus y? Cos pi by 2 plus y is cos 90 plus y. You are going into the second quadrant. Cos is negative there, but since it is pi by 2, it will become sine. So I will say limit y tends to 0, cos of pi by 2 plus y is minus sine y divided by y. Now if you take minus out, you can see that this is nothing but equal to minus 1, because as y tends to 0, sine y by y is nothing but equal to 1. So minus into 1 is minus 1. So one of the approach to solve the problems where the x is tending towards a non-zero value is subtract that value and take it as another variable, so that you can change it to the form of x tends to 0. If I have x tends to pi by 2, now I will take a variable y such that as x tends to pi by 2, y tends to 0. That happens only when y equal to x minus pi by 2. Let us look at one more example to apply this concept what we have learned. Okay, here we go. What we know, here you can see x tends to a, tan of x minus a by x square minus a square. First thing first, what we should have here is I should have a variable which tends to 0. So I will go ahead and write down first y tends to 0. I will write it down. Then I will see what is actually y should be. If y has to tend to 0, then y should be equal to x minus a, because x tends to a, x minus a tends to 0. So I have to take y equal to x minus a. So I will write down here y equal to x minus a. If y equal to x minus a, then what this function will become now? Tan of x minus a, nothing but tan of y divided by x square minus a square. Now here I have to do little bit of work. X square minus a square is nothing but equal to x minus a into x plus a, that is of the form a square minus b square equal to a minus b into a plus b. If y is x minus a, what will be equal to x plus a? X plus a is nothing but x minus a plus 2a. So this is nothing but y plus 2a. I hope you are okay with that. Let me repeat it again. If x minus a equal to y, you want x plus a, because x square minus a square, we want to write it in the form of x minus a into x plus a. X minus a we know anyway, so we'll write down y there, no problem with that. We'll write down y there, no problem with that. For x plus a is nothing but y plus 2a. I hope you are okay with that now. If you substitute now directly, tan y by y is nothing but equal to 1. If you want, again you can write it as sin y by cos y. At the end you will get the same thing. Now this is equal to 1, so that is nothing but 1 into 1 by. You can write one step where you separate them and say limit y tends to 0 tan y by y into limit y tends to 0 1 by y plus 2a. Due to space I haven't written it, but I think you should be okay with that. If y equal to 0, this will become 2a. So your answer is 1 by 2a. So that is how you can solve that particular problem. So the point we have to understand is, when x is not tending to 0, if x is tending to some other variable, try to take a variable such a way that x minus that value equal to variable, so that as x tends to a value, y tends to 0. Then we can convert them into the form either sin x by x or cos x by x. Now let's look at this example, pretty interesting example. We have limit x tends to pi by 2, we have to find out cot of x minus cos of x by pi minus 2x whole cube. Now tell me what should be my y? What should be my y? Because x tends to pi by 2, immediately I'll write down here x minus pi by 2 tends to 0. That means y is my variable which is equal to x minus pi by 2. Or can I say 2y equal to 2x minus pi? I have here pi minus 2x, so what I will do, I will multiply with minus and say minus 2y equal to pi minus 2x. Anything else we need to know? We need to know what is x. X is nothing but equal to y plus pi by 2. There you go. Now once we are done with that, we can substitute in the formula. So let's go ahead and write the first step. The first step will be limit y tends to 0. What is pi minus 2x whole cube? Minus 2y whole cube. What is cot of x? Cot of pi by 2 plus y minus of. What is cos of x? That is again cos of pi by 2 plus y. Okay. So this is nothing but equal to, let me just put a line here so that you will not get confused. Okay, there you go. Okay. Now this is nothing but equal to, let us change the color. Now cot of pi by 2 plus y, what is the value of cot of 90 plus theta? Is nothing but minus tan theta. First I will write down basics. Limit of y tends to 0. I will go to numerator and denominator. Here I will have minus 8y cube. That's easy one, so let me do that fast. Here I will have cot of pi by 2 plus y, that is cot of 90 plus theta, that is minus tan theta or tan y, minus of cos of 90 plus theta, that is again minus sin theta, because in the second quadrant only sin is positive, so it will become minus sin y. This is nothing but equal to limit of y tends to 0. If you simplify that, this is sin y minus tan y by sin y minus tan y by minus 8y cube. Next step, we see here y cube, and if you try to apply 0, now still you are in 0 by 0 form, because sin 0 is 0, tan 0 is 0, 0 minus 0 by 0, 0 by 0 only. So what is our friend in this situation? Always remember 1 minus cos 2 theta equal to 2 sin square theta is mostly used formula in limits. So you have to always remember that, because that will give you either, it will give you sine square, that means it will take care of 2, it will take care of y square. Whatever the y square you have here, it will be taken care by that. So what we will do now, so I will convert it. I will say limit y tends to 0. This is nothing but sin y minus sin y by cos y divided by minus 8y cube. I think we have to move towards right. We will do that. Okay, we have lot of space here. We will leverage it. Okay, what this will be now? Let me just close this. Perfect. Okay, so this will be nothing but equal to limit y tends to 0. I will have sin y into, if you take sin y common, I will have sin y into 1 minus 1 by cos y divided by minus 8y cube. That is nothing but equal to, if you go in this direction for a change, y tends to 0, limit of, this will be nothing but equal to minus sin y is okay. 1 minus 1 by cos y is cos y minus 1, but if I multiply with minus, it becomes 1 minus cos y divided by 8y cube. We'll go to the next step. Next step will be limit y tends to 0. I will take sin y by y, so that will become 1. What is left out is 8y square. So I will put 8y square as it is. And 1 minus cos y is nothing but equal to 2 sin square y by 2. So this, we need to go a little bit more. We will leverage that. That's okay. So the next step will be sin y by y becomes 1 now. We are okay with that. So here, if you check here, we have, so this part is taken care. So what is left out is limit y tends to 0, 2 by 8, that is 1 by 4, into 1 by y square into sin y by 2 into sin y by 2. Sin y by 2 into sin y by 2. That is nothing but equal to. Now I can finish it off. We will say 1 by 4 into sin y by 2. For that you need 1 y by 2. Similarly, sin y by 2. For that you need 1 more y by 2. But we have already with us y square. What we need is y square by 4. So I have to multiply with another 4. Now the next step will be the last step. That will give us this as 1 and this is 1. And what is left out is 1 by 4 into 1 by 4 equal to 1 by 16. Let me just make sure this step you got. Now if you see here, we have 1 by 4 into sin square y by 2 by y square. Now if you make them as sin y by 2 into y by 2. For y by 2 you need 1 y by 2. Another one also you need another y by 2. That means you need y square by 4. But what we have is y square. That is nothing but 4 into y square by 4. So this whole thing will become 1. That 1 by 4 will remain with us. So it will be 1 by 4 into 1 by 4. That's nothing but equal to 1 by 16. I think we have traveled around the whole sheet. But the point to understand is that this is important. Whenever you see non-zero, always take the variable as x minus of that value. Then immediately change the remaining all in terms of y. You will be able to solve it easily, because the fundamental point is we have learned that as x tends to 0, sin x by x is 1, or as y tends to 0, sin y by y is equal to 1. So I should have the value of x or y tending towards 0. For that, I have to take help of another variable and convert the whole expression, given whole function, into variable y and solve it. So I'll catch you in the next session where we will look into limits at the value of infinity. Thanks for your time. Bye for now.